This is a poster presentation that I gave at the first international workshop on rock physics, which was an oil and gas workshop held in Golden, Colorado. I think it's important to make a distinction between data, information, and knowledge. So when we talk about knowledge transferring throughout an asset team or technology transferring throughout a community, we can be specific. Are you transferring files and spreadsheets, or are you transferring insights and wisdom? Because doing one doesn't necessarily mean that you're doing the other. This is a network map of the discussion activity on the Rock Physics group on LinkedIn, which was the first place that I heard about this conference. I think there's value in visualizing who's interacting with who's sitting on the sidelines. Is there a subdivision of expertise or clustering? And there are some key people on the periphery, quite possibly adding links to other relevant networks. These patterns are typical of all social networks. More than 90% of the content's created by less than 10% of the users, the so-called long tail. And sure, maybe it's also biased because some employers prevent their people from contributing or having outside discussions, but I think that's slowly changing. And we're seeing an emergence of new media tools for collaboration and group effort. Wikis are really great because they allow us to organize content beyond static, slow to reproduce publications. Like good software, content should be skill scalable, time scalable, and data scalable. Imagine if your shared drive looked more like a wiki and less like a directory. By building content in the form of a wiki, we can aspire to get a knowledge collection of text, figures, data, software even, where the information is adaptive and evergreen. Now, it's something that takes curating and it takes time, and people need to be inspired to use them. But what's great is that you don't have to sit down and write a whole article on seismic wave equations. You can get started by simply correcting a typo or by improving the wording in a sentence. Many companies have internal wikis for capturing and spreading their intellectual property, but there's also many open wikis that can be edited and accessed by anyone. We put a lot of our stuff on Agile Wiki at agileinterpretation.com. And I think you're going to see people be increasingly recognized, not only for what they know, but for their willingness and effectiveness in sharing it. Innovation and creativity stem from openness. Crowdsourced initiatives like the Open Seismic Repository or the Virtual Seismic Atlas are precursors of a semantic web environment. On AgileWiki, we've started cataloging and creating links to open data sets. Here's a map of SegWi data that you can click on and download data right to your workstation right now. Similarly, the Marmusi and 6B models are great examples of projects jointly supported by professional societies, by industry, and by academia. I think we need more of this, especially for the rock physics community. We should assemble and share standard data sets, a standard full field Earth model. I'm not exactly sure what this would look like, so if you have a vision or an analog, I'd love to learn about your ideas. Since January 2011, we've published 4 cheat sheets built from stuff that we use all the time. Now, they're freely available and accessible on our blog, and they've become fairly popular. What's impressive, though, isn't the size of the audience, but how feedback has really extended the utility of these tools. Our consumers are becoming creators. Cheat sheets are a different form of creating content, and it's changing behaviors and enabling frank communication. You may not be able to predict who will find your knowledge useful, so why not build a barrier-free tool that facilitates collaboration and understanding? For an expert or specialist, it can be difficult to articulate his or her expertise or technical judgment to a novice. But if you do some programming or craft an algorithm, a series of steps, statements, and conditions, it forces you to filter concepts based on relevance and build something ultimately that others can use. For us, it's about putting stuff into people's hands that positively influences their work and makes them more productive. And it's about raising the bar with little productivity tools. This is an example of our AVO app for Android mobile devices. We build these apps using Google's App Inventor. Now, I'm not a software programmer, but I have done some scientific computing. And Google's made it really easy to, without a lot of prior programming experience, make apps for actually getting real work done. I find this pretty exciting, and we write about our motivation behind building these apps, and we make video tutorials for our blog, and we put help documents and more information about the math and science and so on the wiki. So check them out and let us know if you find them useful. Rock physics is growing as an interdisciplinary link in oil and gas. It means dealing with more specialists with more interests and more obligations. The question is not, are we connected, but how should we best be connecting? Our ability to share is accelerating and becoming easier, and content is becoming indistinguishable from software. There's going to be more pressure to package highly contextualized information, data, interpretations, designs, and errors that somebody else is going to have to use. That's pretty much all I wanted to say on this video. It was my first go at making one, so I'd love to hear what you think, and if you have any comments or questions, that'd be great. Thanks a lot for listening.